NASA, the vanguard of humanity's reach into the cosmos, continues to inspire with groundbreaking innovations that promise to redefine our understanding of the universe and our place within it. Yet even as the agency pushes the boundaries of what's possible, it navigates a complex landscape of operational challenges and critical funding decisions that underscore the intricate balance between ambitious vision and terrestrial realities. At the heart of NASA's forward-looking strategy lies the NASA Innovative Advanced Concepts NIAC program, a pivotal initiative designed to foster visionary yet credible technologies that could fundamentally change the possible in aerospace. On June 23, 2025, NASA highlighted the latest advancements emerging from this program, showcasing how it engages America's innovators and entrepreneurs in transforming what once belonged to science fiction into tangible reality. These concepts are not mere theoretical exercises, they are practical solutions aimed at supporting future missions. From resource acquisition on distant planets to enhancing the safety and efficiency of space travel, and even providing benefits that resonate back on Earth. The NIAC portfolio is particularly focused on enabling a sustained human presence on Mars, tackling critical barriers one innovative study at a time. Among the standout NIAC projects is a revolutionary system designed to separate oxygen and hydrogen gas bubbles from water in microgravity without direct contact. This technology is vital for long-duration crewed missions such as a journey to Mars, where water and oxygen supplies are critically limited. Researchers have found that this concept is remarkably robust, capable of handling power fluctuations requiring less pristine water, operating across a wide temperature range, and exhibiting greater resistance to bacteria compared to current oxygen generation systems. The team, now advanced to another phase of study, plans to test a larger version in microgravity, aiming to prove its potential as a game-changer for future deep space endeavors. Another critical challenge for Martian exploration is water contamination. Unlike Earth's relatively pure water, Mars's water ice is laced with toxic perchlorates and chlorates, posing severe health risks to astronauts and corrosive threats to equipment. NIAC-funded researchers are developing a regenerative perchlorate reduction system that leverages naturally occurring bacteria's enzymatic pathways. These pathways, engineered into resilient bacteria, can biochemically convert perchlorate and chlorate into harmless chloride and oxygen. This breakthrough could unlock Mars's abundant water supply, allowing future human explorers to thrive on the red planet. Beyond life support, protecting human health from the harsh space environment is paramount. Chronic radiation exposure remains a significant threat for long-term missions, including the extensive travel to and from Mars. One NIAC study is exploring a novel approach, transplanting new, undamaged mitochondria, the cellular powerhouses, into radiation-damaged cells. By using complex 3D human cell models grown in a lab, researchers aim to demonstrate how targeted mitochondrial replacement therapy could regenerate cellular function after both acute and prolonged radiation exposure. While in its early stages, this research holds profound implications not only for significantly reducing radiation risks for space crews but also for treating a wide array of age-related degenerative diseases on Earth linked to mitochondrial dysfunction. Finally, ensuring astronaut mobility and protection in the extreme Martian environment is being addressed through advancements in spacesuit technology. Engineers are proposing a digital template to generate custom, cost-effective, high-performance spacesuits. This concept utilizes digital thread technology to create suits that not only shield crew members from the harsh conditions but also provide the necessary mobility for daily exploration and scientific excursions. A recently completed NIAC study focused on digitally mapping key spacesuit components and manufacturing processes, identifying technological gaps and developing a conceptual digital thread model for future development and operational support, promising an unprecedented level of customization and efficiency for Martian expeditions. Beyond enabling human presence, NASA's quest extends to the fundamental question of life itself. Astrobiologist Batul Kakkar, a University of Wisconsin-Madison professor and NASA-funded research leader, highlighted on June 23, 2025, what NASA is truly looking for in space: signs of life even if it doesn't conform to our terrestrial expectations. By studying how microbes survive in extreme environments on Earth, Kacker's work aims to broaden our understanding of what life can be, preparing scientists to recognize a wider range of chemical biosignatures that advanced telescopes are now capable of detecting. This shift in perspective is crucial for identifying extraterrestrial lifeforms that may not resemble anything we've encountered. However, the ambitious trajectory of space exploration is not without its earthly constraints. Even as NASA champions these visionary projects, the agency faces the prospect of proposed budget cuts, as reported by Axios on June 23, 2025. Such cuts could jeopardize crucial research and jobs, particularly in states like Tennessee, potentially slowing the very progress that NIAC and other programs aim to accelerate. Moreover, the inherent complexities of space operations continue to present challenges, as evidenced by the repeated delays in the SpaceX and NASA-supported Axiom Space crewed mission, also reported on the same day. These postponements, while frustrating, underscore the meticulous planning and rigorous safety protocols required for human spaceflight. The path to the stars is paved with both audacious vision and meticulous problem-solving. NASA's commitment to fostering far-out technology, coupled with its profound search for life beyond Earth, paints a picture of an agency relentlessly pushing the boundaries of human knowledge and capability. Yet the success of these endeavors hinges not only on scientific ingenuity but also on sustained support and the ability to navigate the practical realities of funding and operational execution. As the agency continues to solicit new visionary ideas through programs like NIAC, the future of aerospace promises a cascade of transformative developments provided the necessary investments and resolve remain firmly in place. The roar of rocket engines has become an increasingly familiar sound along Florida's Space Coast, a testament to a burgeoning era of private space enterprise and ambitious national endeavors. Just as humanity continues its orbital dance aboard the International Space Station, facing both scientific challenges and the sheer beauty of Earth from above, the launch pads below are setting unprecedented records, signaling a profound shift in the pace and accessibility of space. This relentless activity, particularly driven by commercial giants like SpaceX, is not merely a numbers game but a foundational element shaping the future of exploration, communication, and defense in orbit and beyond. The year 2024 concluded with a remarkable 93 orbital launches from the Space Coast, shattering the previous record of 72 set in 2023. This explosive growth is poised to continue, with the U.S. Space Force indicating that the infrastructure could support an astonishing 156 launches in 2025. As of June 23, 2025, the Space Coast has already seen 53 orbital launches, including one hypersonic missile test, demonstrating a sustained high tempo. This surge is predominantly fueled by SpaceX, which accounts for 50 of the 2025 launches to date with its workhorse Falcon 9, along with 2 Atlas V missions from United Launch Alliance (ULA) and the much-anticipated debut of Blue Origin's New Glenn. SpaceX's strategy of rapid reusability is undeniably the primary driver behind these figures, with Falcon 9 boosters routinely completing dozens of flights, setting new industry benchmarks for turnaround times, sometimes as short as 2 days and 20 hours between launches from the same pad. This incredible efficiency has not only accelerated the deployment of vast constellations like Starlink but also allowed SpaceX to pick up national security missions originally slated for ULA, as the latter works to certify its next-generation Vulcan Centaur rocket. Amidst this flurry of activity, human spaceflight continues to capture headlines, albeit with the inherent complexities of orbital mechanics and international coordination. The planned Axiom Space X-4 mission, a private crewed flight to the International Space Station (ISS), has faced yet another delay, now targeting June 25 after multiple postponements. NASA is taking additional time to analyze a leak repair on the Russian segment of the space station, underscoring the intricate dance of scheduling and safety paramount for human missions. X-4, commanded by veteran astronaut Peggy Whitson, will carry a multinational crew including Shubhanshu Shukla of India, Sława Uznansky of Poland, and Tibor Kapu of Hungary for a 14-day stay. This commercial flight is part of a growing trend of private entities expanding access to low Earth orbit, complementing NASA's ongoing crew rotations.
The ISS currently home to Expedition 73 with 7 crew members from JAXA, NASA, and Roscosmos. Remains a vital hub for scientific research and international cooperation. Life aboard the orbital outpost is a unique blend of cutting-edge science, meticulous maintenance, and profound personal reflection. Expedition 73 flight engineer Anne McLean recently shared a fascinating observation about auroras, noting that what she initially perceived as white was actually a very pink-hued phenomenon, leading her to delve into the atmospheric conditions that dictate aurora colors. Green, the most common, occurs from oxygen molecules at 60 to 150 miles altitude, while red signifies oxygen impacts at higher, less dense altitudes. Fellow NASA astronaut Nicole Ayres, a newly promoted lieutenant colonel in the U.S. Air Force, also offered a poignant perspective during a podcast interview, describing Earth from the cupola as so fragile a view that has instilled in her a deeper commitment to environmental stewardship. Beyond these ethereal observations, the crew diligently pursues a packed schedule of scientific experiments. This past week saw work on Realm, an RFID-enabled system using free-flying robots to track equipment and biomonitor a Canadian-built vest for collecting physiological data. Russian cosmonauts Sergei Ryzhikov and Alexei Zabritsky continued a respiratory study using acoustic sensors, while Commander Takuya Onishi and others performed critical station-keeping tasks, including inspecting and cleaning the module windows and hatch seals. Looking ahead, the horizon of space exploration promises even more ambitious endeavors. Beyond the routine Starlink deployments and ISS resupply missions, the Space Coast's launch manifest includes critical national security payloads, further Amazon Kuiper constellation launches, and the long-awaited debut of Blue Origin's New Glenn, which has seen its first mission, NG-1 Blue Ring Pathfinder, delayed due to technical issues and booster recovery concerns. Lunar missions under NASA's Commercial Lunar Payload Services (CLPS) program are also ramping up, with Intuitive Machines, Firefly Aerospace, and Draper planning Nova C and Blue Ghost landers targeting various lunar regions, including the far side and the South Pole, to conduct scientific research and prospect for resources. Human deep space missions are also on the horizon, with NASA's Artemis 2 set for early 2026, sending 4 crew members on an orbital mission around the Moon, followed by Artemis 3 in summer 2027, which aims to return humans to the lunar surface. The continuous innovation in reusable rocketry, coupled with growing government and private investment, is transforming space from an exclusive frontier into an increasingly accessible domain, driving a new era of exploration, commerce, and scientific discovery that will undoubtedly redefine our relationship with the cosmos. The vast expanse of space continues to be a crucible for human endeavor, a realm where ambition clashes with the unforgiving realities of orbital mechanics and complex engineering. Recent developments from the front lines of space exploration underscore both the triumphs of human resilience and the persistent challenges that define our journey beyond Earth, from unexpected extended stays to the meticulous dance of launch schedules. In a poignant testament to human adaptability and the robust nature of international collaboration, NASA astronauts Sunita Suni Williams and Barry Butch Wilmore recently made a stellar return to Earth after an extraordinary 9-month stay aboard the International Space Station (ISS). What was originally planned as a brief 8-day visit stretched to nearly 300 days following critical technical issues with Boeing's Starliner spacecraft. Their intended ride home. A helium leak shortly after Starliner's launch last June 2024 necessitated its return to Earth without its crew, leaving Williams and Wilmore to integrate fully into the ISS team. Their unexpected extension saw them joined by NASA's Nick Hague and Russian cosmonaut Alexander Gorbanov as part of the Crew 9 mission, before the quartet finally splashed down safely off the coast of Florida on March 18, 2025, aboard a SpaceX Dragon capsule. This prolonged mission, while challenging, became a powerful demonstration of the resilience and resourcefulness of astronauts and the multi-layered safety protocols designed to ensure their well-being even when plans go awry. Addressing earlier suggestions by former President Donald Trump that they had been virtually abandoned, Butch Wilmore unequivocally stated in a CNN interview, "We don't feel abandoned, stuck, or stranded. That's been the narrative from day one. But that is, again, not what our human spaceflight program is about." Their return not only marked the successful conclusion of an extended mission but also highlighted the critical role of SpaceX's Dragon in providing a reliable alternative transport system. While some astronauts were making their long-awaited return, the complexities of space travel continued to manifest in other areas. The joint SpaceX and NASA launch of a crewed Axiom Space mission, for instance, has once again faced delays. Such postponements are a common albeit frustrating aspect of space operations, often stemming from a confluence of factors including intricate technical checks, unfavorable weather conditions, and precise orbital mechanics. Each delay, while impacting schedules and costs, underscores the paramount importance placed on crew safety and mission success, reflecting the meticulous nature of spaceflight protocols where no detail can be overlooked. Life aboard the ISS, even for extended periods, is far from static. Astronauts maintain rigorous routines to counteract the physiological effects of microgravity. NASA astronaut Tracy Dyson, for example, has shed light on the critical importance of staying fit in orbit. Without the constant pull of gravity, astronauts face challenges like bone density loss and muscle atrophy, necessitating daily exercise regimens using specialized equipment. This dedication to physical well-being is not merely about comfort, it's vital for their ability to perform mission-critical tasks and for their successful readaptation to Earth's gravity upon return. Beyond the physical demands, the unique vantage point of orbit offers unparalleled views, inspiring awe and contributing to scientific observation. Astronauts frequently share their breathtaking observations, with one recently noting that when it comes to auroras, pink is the new white. These vibrant displays of light caused by solar particles interacting with Earth's magnetic field are a constant reminder of our planet's dynamic environment and the wonders visible from above. The recent flurry of activity in space, from the triumphant return of long-duration astronauts to the ongoing challenges of launch schedules and the daily realities of orbital life, paints a vivid picture of humanity's evolving relationship with the cosmos. It showcases the incredible feats of engineering and human endurance required for space exploration, while also emphasizing the iterative safety-first approach that defines the industry. As commercial space ventures like Axiom Space continue to expand access to orbit, and as agencies like NASA push towards deeper space missions to the Moon and Mars, the lessons learned from these orbital experiences, the adaptability in the face of unexpected challenges, the unwavering commitment to safety, and the continuous pursuit of scientific understanding, will be invaluable. The future of space exploration will undoubtedly continue to be a dynamic interplay of innovation, perseverance, and the occasional yet necessary pause for perfection. In a bold stride towards an audacious future, NASA is once again demonstrating its commitment to transforming the realm of science fiction into tangible reality. The agency's innovative Advanced Concepts (NIAC) program continues to serve as a crucial incubator for visionary yet credible technologies poised to redefine humanity's reach across the cosmos. This proactive investment in far-out tech, however, arrives amidst looming financial uncertainties, highlighting a critical tension between ambitious exploration and the practicalities of funding. At the heart of NASA's forward-thinking strategy is the NIAC program, designed to engage America's brightest innovators and entrepreneurs in developing groundbreaking solutions for future aerospace missions. These concepts, as highlighted in a recent NASA dispatch published on June 23, 2025, are diverse, spanning from enhancing safety and efficiency in space travel to the profound goal of establishing a sustained human presence on Mars and even delivering benefits back to Earth. The program's philosophy is clear: to change the possible one innovative idea at a time. Among the most compelling NIAC-backed studies are those directly addressing the formidable challenges of long-duration spaceflight and Martian colonization. For instance, a pioneering study is exploring a system to separate oxygen and hydrogen gas bubbles from water in microgravity without direct contact. This technology, crucial for recycling precious resources on extended missions, has shown promising results, handling power fluctuations requiring less clean water, operating across a wide temperature range, and exhibiting greater resistance to bacterial contamination than current oxygen generation systems. The team now advancing to another phase of study.
aims to test a larger version in microgravity, hoping to prove its potential as a game-changer for journeys to Mars.
Another critical innovation targets the detoxification of Martian water. Unlike Earth's pristine sources, water on the red planet is laden with toxic perchlorates and chlorates, posing severe health risks to astronauts and corroding vital equipment.
Researchers are developing a regenerative perchlorate reduction system that harnesses naturally occurring bacteria, engineering their perchlorate reduction pathways into resilient bacterial strains. This biochemical process converts these harmful molecules into harmless chloride and oxygen, potentially unlocking an abundant safe water supply for future Martian inhabitants. Beyond resource management, safeguarding human health in the harsh deep space environment is paramount. Chronic radiation exposure remains a significant threat to long-term missions, including the arduous journey to Mars.
One NIAC study is delving into the novel concept of transplanting new
undamaged mitochondria, the cellular powerhouses, into radiation-damaged cells. Utilizing complex 3D human cell models grown in labs, researchers aim to demonstrate how this targeted mitochondrial replacement therapy could regenerate cellular function after both acute and prolonged radiation exposure. While still in its nascent stages, this research not only holds immense promise for protecting astronauts but could also lead to treatments for various age-related degenerative diseases on Earth linked to mitochondrial dysfunction. Finally, ensuring astronauts are equipped for the extreme Martian environment is being reimagined through advanced spacesuit development. Engineers are proposing a digital template approach to generate custom, cost-effective, and high-performance spacesuits. This concept leverages digital thread technology to create suits that offer superior protection while maximizing mobility for critical exploration and scientific endeavors on Mars. A recently completed NIAC study focused on mapping key spacesuit components and manufacturing processes to digital models, identifying technological gaps
and benchmarking capabilities, laying the groundwork for future spacesuit design and operational support.
While NASA's vision for future exploration remains expansive, encompassing everything from Martian outposts to black hole research and Venusian atmospheric monitoring, a recent report from Axios on the same day, June 23, 2025, casts a shadow of uncertainty. Proposed budget cuts for NASA could jeopardize critical research initiatives and consequently jobs in key states like Tennessee. Such fiscal constraints could potentially slow the very progress that programs like NIAC are designed to accelerate, impacting the pipeline of innovative technologies crucial for future missions. Meanwhile, more immediate operational activities continue, as evidenced by NASA research planes conducting low-altitude flights over Southern California, likely for atmospheric studies or flight testing, underscoring the broad spectrum of the agency's ongoing work.
Ultimately, NASA's unwavering commitment to pushing the boundaries of what's possible remains a beacon of human ingenuity.
The NIAC program exemplifies this spirit, transforming audacious ideas into actionable research that promises to redefine space exploration. Yet the realization of these ambitious visions hinges not only on scientific breakthroughs but also on sustained support and strategic investment. As NASA continues to invite innovators to contribute to its 2026 Phase 1 solicitation, the journey towards a multiplanetary future will undoubtedly be shaped by both the brilliance of its concepts and the political and economic landscape that enables or constrains their development. Humanity's enduring quest to venture beyond Earth has long fixated on Mars, the enigmatic red planet, as our next frontier. Recent groundbreaking discoveries and a surge of innovative technological advancements are rapidly transforming this ambitious vision from science fiction into an increasingly tangible reality, paving the way for a sustained human presence on our celestial neighbor. The foundational understanding of Mars has been meticulously built over decades by robotic explorers, none more persistent than NASA's Mars Odyssey orbiter. Launched in 2001, this venerable spacecraft marked its 60,000th orbit of the red planet on June 23, 2015, and continues to operate as the longest-serving spacecraft in orbit around another planet. Odyssey's continuous observations have fundamentally reshaped our perception of Mars from a dry, barren world to one holding widespread subsurface water ice. Its data on Martian weather and radiation have been crucial for planning future human missions, according to NASA, and it serves as a vital communications relay for surface missions. Just last month it delivered a first-of-its-kind panorama of the Axiom Space volcano, a testament to its enduring utility. Building on this legacy, a new study led by University of Mississippi planetary geologist Erica Luzzi has delivered a discovery that could be a definitive game-changer for future human missions: strong evidence of water ice located less than 1 meter beneath the Martian surface in the Amazonas Planitia region. This finding, gleaned from high-resolution satellite images from the Mars Reconnaissance Orbiter's HiRISE camera, reveals telltale signs including ice-exposing craters and polygonal terrain patterns that typically indicate near-surface ice. Luzzi identifies Amazonas Planitia as the perfect compromise for future missions, noting that its middle latitudes receive sufficient sunlight for equipment while remaining cold enough to preserve these vital ice deposits, making it an ideal candidate for humanity's first Mars landing site. The significance of this discovery extends far beyond a mere drink for future astronauts. As Luzzi emphasizes, if we're going to send humans to Mars, you need H2O, and not just for drinking but for propellant and all manner of applications. This concept, known as in situ resource utilization (ISRU), is paramount given the vast distances involved. Water can be broken down to provide oxygen for breathing and hydrogen for rocket fuel, drastically reducing the need to transport heavy resources from Earth and making long-duration missions feasible. The presence of accessible ice also holds exciting implications for astrobiology, potentially preserving biological markers or even harboring microorganisms. To truly realize these ambitious Martian aspirations, NASA is actively fostering what it calls far-out tech through its innovative Advanced Concepts NIAC program. This initiative nurtures visionary yet credible concepts designed to change the possible in aerospace, engaging America's innovators and entrepreneurs. The NIAC portfolio addresses critical challenges for deep space human exploration, particularly for a future human presence on Mars. One vital area is resource production. A NIAC study is investigating a system to separate oxygen and hydrogen gas bubbles from water in microgravity without direct contact. This technology, which requires less clean water, works across a wide temperature range and is more resistant to bacteria than existing systems, could be a great fit for a long trip to Mars, offering a sustainable method for producing breathable air and fuel components. Complementing this, researchers are developing a regenerative perchlorate reduction system that utilizes naturally occurring bacterial enzymes to detoxify Martian water, transforming toxic perchlorates and chlorates into harmless chloride and oxygen. This would unlock Mars' abundant, albeit contaminated, water supply for human consumption and equipment use. Beyond resources, ensuring astronaut health and safety in the harsh Martian environment is paramount. Chronic radiation exposure poses a significant threat to long-term stays in space. An NIAC study is exploring targeted mitochondrial replacement therapy, transplanting new undamaged mitochondria into radiation-damaged cells to regenerate cellular function. While still in early stages, this research could significantly reduce radiation risks for crewed missions and even offer benefits for treating age-related degenerative diseases on Earth. Furthermore, future Mars explorers will require highly specialized protection. Engineers are conceptualizing advanced spacesuits using digital thread technology to generate custom, cost-effective, high-performance suits. This digital template approach aims to protect crew members from the extreme Martian environment while providing the mobility needed for extensive scientific excursions, ensuring astronauts can suit up for Mars and beyond in a way like never before. These diverse advancements, from the discovery of accessible water ice to the development of self-sufficient life support systems, radiation therapies, and advanced spacesuits, collectively represent crucial stepping stones toward establishing humanity's foothold on the Red Planet. By continuously pushing the boundaries of exploration and collaborating with innovators, NASA is not only advancing concepts for future missions but also energizing the broader space economy. The journey to Mars is a testament to human ingenuity, and with each technological leap, the once distant dream of living among the stars inches closer to becoming our shared destiny. The lunar frontier, long a beacon of human ambition and scientific curiosity, is currently a crucible of both significant setbacks and burgeoning strategic competition, even as new scientific opportunities emerge. Recent developments paint a complex picture of humanity's ongoing and increasingly crowded journey to Earth's closest celestial neighbor. Just weeks ago, on June 5, 2025, the Moon witnessed another challenging chapter in private space exploration as Japan's ispace experienced its second consecutive lunar landing failure. Their Resilience lander attempting a touchdown in the Mare Frigoris region lost contact during its descent, ultimately impacting the surface. NASA's Lunar Reconnaissance Orbiter (LRO) has since captured a stark image of the crash site, a distinct dark smudge or regolith surrounded by a subtle bright halo indicative of the hard impact disturbing the lunar dust. This incident, occurring approximately 2.4 kilometers from the intended landing zone, sadly also claimed the small microrover Tenacious, built by a Space European team, and a poignant piece of art. Michael Genberg's Moonhouse, a tiny red and white model meant to symbolize human creativity extending to the Moon. While a significant setback for ispace following their April 2023 crash, NASA notes that the imagery provides invaluable data, crucial for understanding the precise failure mechanisms and informing future lunar landing attempts by both private entities and national agencies. The inherent difficulty of lunar landings, where every system must perform flawlessly, continues to be underscored by such events. Yet beyond the technical challenges, the race to the Moon is increasingly shaped by geopolitical currents. A sobering assessment from the European Space Agency warns of profound consequences stemming from the Trump administration's proposed 50% cuts to NASA's budget and the potential cancellation of 40 science projects. Such reductions, they caution, could not only jeopardize 19 joint projects and extinguish critical continental supply chains for spaceflight technology, but also effectively sideline Europe from the burgeoning lunar landscape. This financial contraction for Western space programs comes at a pivotal moment, potentially paving the way for China's escalating lunar ambitions. Beijing, according to former NASA engineer Casey Handmer, plans to land on the Moon within 5 years and establish a permanent base within the next decade. Handmer starkly warns that China will claim prime real estate around the polar craters, defend it as the sovereign territory of a nuclear-armed state, and place a permanent chokehold on the future of humanity. This aligns with what Chinese President Xi Jinping has dubbed China's eternal dream, a comprehensive conquest of space extending to asteroid mining, Mars colonization, and deep space stations, all part of a broader national rejuvenation strategy. Critics argue that NASA, once the epitome of technical excellence and a bulwark against Soviet space dominance, has become a bloated bureaucracy clinging to outdated technology like the 60-year-old Space Launch System, while seemingly ignoring the paradigm shift brought about by companies like SpaceX, which have dramatically reduced launch costs. The rejection of Jared Isaacman as SpaceX ally for the NASA administrator role, reportedly due to a spat between Elon Musk and Donald Trump, is seen by some as a symbolic moment, highlighting how internal political squabbles could jeopardize the West's lead in the new space race. Nations like Russia, Venezuela, Pakistan, and Belarus are already aligning with China, signaling a clear division in the unfolding scramble for space. Amidst these grand aspirations and geopolitical tensions, the Moon also presents unique scientific opportunities, sometimes unexpectedly. Astronomers recently refined the orbit of asteroid 2024 YR4, which was initially feared to be on a collision course with Earth. Thanks to data collected by the James Webb Space Telescope (JWST), updated calculations now suggest a 4.3% chance that the 80-meter-wide asteroid could strike the Moon on December 22, 2032. While still a relatively low probability, Dr. Dimitra Atri, principal investigator at New York University Abu Dhabi's Space Exploration Laboratory, views this as an unprecedented scientific opportunity. Such an event would allow researchers to observe the formation of a major lunar crater in real time, with modern orbital instruments providing invaluable data on how impacts shape planetary surfaces and aiding in the development of planetary defense strategies. Although the asteroid is currently too distant for Earth-based telescopes, its 2028 flyby will be a critical window for more precise tracking, helping to account for factors like the Yarkovsky effect, which subtly alters asteroid trajectories. This potential impact also reignites discussions about planetary defense following the success of NASA's DART mission in 2022, which demonstrated the feasibility of altering an asteroid's path. While a deflection mission for 2024 YR4 would require 3 to 5 years of preparation, the 2028 observations will provide crucial lead time if such action ever becomes necessary. Though the asteroid's composition remains unknown. Adding to the dynamic lunar landscape, NASA is also exploring innovative, albeit less dramatic, ways to leverage the Moon itself for scientific purposes. The agency plans to use light bouncing off the Moon's surface to calibrate space hardware. This technique would allow for precise adjustments and verification of instruments, ensuring the accuracy of data collected from various missions. The Moon therefore remains at the heart of humanity's evolving relationship with space. From the humbling realities of private sector failures and the high-stakes geopolitical competition for lunar dominance to the quiet brilliance of scientific ingenuity and the dramatic potential of celestial impacts, our nearest neighbor continues to challenge, inspire, and shape the future of space exploration. The coming years will undoubtedly determine whether the lunar frontier becomes a shared domain of scientific progress and international cooperation, or a new arena for strategic rivalry.